Okay, welcome ladies and gentlemen, and what we're looking at right now is the last example from Tuesday's lessons that we didn't quite finish off. It wants to determine if each system can be solved, then they want me to solve the system. So again, following the same procedure that we looked at before, I'm going to take a look at the normals. The normals are going to tell me most of the information that I need. So 1, 3, -1, normal 2, 2, 1, and 1, and normal 3 is 1, -2, and 2. I take a little bit of time and look at those, and I come to the conclusion that none of them are scalar multiples. I'm going to ask my audience and see if they agree, and my audience agrees. None are scalar multiples. So I can say that n1 does not equal a scalar multiple of n2, does not equal a scalar multiple of n3, where k1 and k2 are scalars from the real number system. So therefore, no planes are parallel, and therefore I think we're talking about case 3. Okay, and case 3, let's remember, is the case where we have either that or we have that's a line of intersection, or you have a point of intersection. Okay? So let's take a look. At this point, we're going to check out the coplanarness. I think we invented a new word in one of the classes. So we're going to check normals for coplanarness. Remember? Put it on Wikipedia. In a little while, if enough of us agree that it's a word, it'll become a word. So check for coplanarness, and we're going to do that by using the triple scalar product, which is n1 cross n2 dot n3. Okay, and we're going to look for whether or not that equals 0, and if it does, then they're coplanar, and if it doesn't, then they're not. So let's take a look at n1 cross n2. So it'll be 1, 3, -1, 1, 3, -1, 2, 1, 1, 2, 1, 1, goodbye, goodbye. Down products subtract up products, so it's going to be 3 plus 1, which is 4. It's going to be -2 subtract 1, which is -3. And it's going to be 1 subtract 6, which is -5. Checking to my audience to make sure everything's fine with that. They're agreeing. So this is n1 cross n2. We're now going to dot that with n3. And it's going to be 4 plus 6, take away 10, and lo and behold, we've got 0. That means that we are looking at coplanar. That means they are coplanar. Hold on, let me think. I sort of thought this was going to be a point of intersection. If they're coplanar, then it's either no point of intersection or it's a line of intersection. That's interesting. Okay, so let's continue. Something new every day. There you go. Let's make sure I did everything right. 4 plus 6 minus 10. Looks good. All right. So therefore, either no point of intersection or line of intersection. Okay, so let's take two of the planes. Let's take plane 1. And let's do x plus 3y minus z equals -10. Let's take plane, how about we take plane 3? And we take x minus 2y plus 2z equals -4. And let's get rid of the x's. So using elimination, we're going to end up with 5y, -3z, -6, which is going to be y equals -6 over 5 plus 3 over 5 z. That's one of my equations. Let's sub that back in. I'm thinking I'll sub it back into plane 1. It has to go into either plane 1 or plane 3 at this point, so I'm going to choose plane 1. So it's going to go back as x plus 3, and what's going in is negative 6 over 5 plus 3 over 5z minus z equals minus 10. So that's going to be x minus 18 over 5 plus 9 over 5z minus z equals negative 10. Don't like those 5s. Give me nightmares. So let's multiply through by 5. 5x minus 18 plus 9z minus z equals, no, 5x minus 18 plus 9 minus 5z equals negative 50. Remember, we multiplied through by 5? So this will be 5x minus 18 plus 4z equals negative 50. Oh, goodness. Using a calculator, because I'm not good with mental math. 32. So I've got 5x equals negative 32 minus 4z. So you've got x equals negative 32 over 5 minus 4 over 5z. Well, if I'm going after a line of intersection, what I'll do now is I will let z be a parameter, and I'll be able to come up with a line. But the problem is I've either got a line between plane 1 and plane 3. I'm not for sure that I've got a line between all 3 planes. So here I'm at a dilemma. Should I first decide if there's a line of intersection between all 3, in which case I'll take these values and plug them into plane 2? Or should I finish off and determine this line and then take the point and plug it back in? It doesn't matter. Okay, at this point it's a choice. It's what you want to do. Why don't we go for the second option? That way if I find it and we're good to go. So using method 1, with method 1, what we're going to do is we're going to let t equal z, where t is an element of the real number. And so the line of intersection between plane 1 and plane 3 is given by negative x equals negative 32 over 5 minus 4 over 5 t. Y equals negative 6 over 5 plus 3 over 5 t, and z equals t. So in vector notation, we're looking at negative 32 over 5, negative 6 over 5, comma 0, plus negative 4 over 5, negative 3 over 5, 1. Notice that these are the same values, so if I was able to take away or add enough to be able to get it over 5, that would be good enough. But to be honest with you, all I need to do is check if this point lies on plane 2. Plane 2 is given by 2x plus y plus z equals 8. Is that the one? Yeah. So you get 2, negative 32 over 5. Can you guys see? Yes, you can. Plus negative 6 over 5 plus 0 equals 8. Negative 64 over 5 minus 6 over 5. Ladies and gentlemen, is there any chance in heck that a negative 64 over 5 take away 6 over 5 is going to equal 8? No. So, guess what? Therefore, point on line of intersection does not lie on line of intersection. No, does not lie on plane 2. Therefore, no points of intersection between all 3 planes. Looking out to my audience, does that make sense? Your other choice, of course, at this point, your method 2, just because I'm all about choice. Method 2. Method 2 was to take our x that equals negative 32 over 5 minus 4 over 5 z, and our y that equaled negative 6 over 5 plus 3 over 5 z, and sub into the second plane. So again, the second plane was 2x. 2x plus y plus z equals 8. So if these are going to satisfy each other, what we're going to do is look for the z's that'll satisfy all of them. So it becomes 2, negative 32 over 5, negative 4 over 5 z, plus negative 6 over 5 plus 3 over 5 z, plus z equals 8. So negative 64 over 5, negative 8 over 5 z, negative 6 over 5 plus 3 over 5 z plus z. Well, I've got 2 different z's. Haha. All right, z equals 8. Okay? I hate the 5s. Feel like I'm being overrun by 5s. Multiply everything by 5s. So I've got negative 64, take away 6 is negative 70, yes? Negative 70 going over to the other side would be 110 when you add it to 40. Negative 8 plus 8. So what values of z will allow that to happen? Therefore, no values of z will satisfy this equation. Therefore, no points of intersection between all 3 planes. And it looks like this. Wee, 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 wee. Goodbye, kids. Gotta go. Gotta take my kids somewhere. See ya.